Students, we are given two questions. We are expected to discuss the nature of roots. The first one, okay, let us consider p of x to be equal to x raised to the power 2018 plus 947 x raised to the power 1950 plus 15 x raised to the power 8 plus 26 x raised to the power 6 positive 2019. Now let us write down the sign changes. So we got a positive here, positive here, positive here, positive here, positive here. So zero sign change, zero sign change, zero sign change, zero sign change. So by Descartes' rule of signs, we observe that p of x, okay, as zero sign changes. So this means p of x has no real positive roots. Okay, so this is the conclusion. Okay, now consider p of negative x. So this is going to be negative x raised to the power 2018 positive 1947 negative x raised to the power 1950 positive 15 negative x raised to the power 8 positive 26 negative x raised to the power 6 positive 2019. Now this number is even. Okay, so negative term raised to the power of an even quantity will result in a positive sign. Okay, so that's going to be plus x raised to the power 2018. Similarly, in this case, 1947 x raised to the power 1950. Similarly, you get positive 15 x raised to the power 8, positive 26 x raised to the power 6, positive 2019. So if you were to write down the sign changes, okay, if you were to write down the sign changes, positive, 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 okay, so zero sign change, zero sign change, zero sign change, and zero sign change. Okay, so therefore by Descartes' rule of signs, we observe that p of negative x has zero sign changes. So this would mean that p of negative x has no real negative roots. Okay, you can state that value, you can state that statement, no negative real roots or real negative roots. Okay, so this would mean p of x has all its roots imaginary. P of x is equal to x to the power 5 negative 19 x to the power 4 positive 2x cubed positive 5x squared positive 11. This is what is given. Okay, so write down the sign changes. So we got a positive, negative, positive, positive, and positive. We got one sign change, one sign change, zero sign change, and zero sign change. So clearly p of x has two sign changes. By Descartes' rule of signs, p of x will have at most two positive real roots. Okay, there are two positive real roots for this polynomial. Okay, now consider p of negative x. So this is going to be negative x raised to the power 5, negative 19, negative x raised to the power 4, positive 2, negative x raised to the power 3, positive 5, negative x raised to the power 2, positive 11. This will give you negative x raised to the power 5, negative 19 x raised to the power 4, negative 2 times x raised to the power 3, positive 5 times x squared, positive 11. So write down these sign changes. You got a negative, 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 positive, and positive. No sign change, no sign change, one sign change, no sign change. So therefore, by Descartes' rule of signs, P of x, or in other words, P of negative x has been observed to have just one sign change. Okay, so this means P of negative x will have at most one negative real root. Okay, so m has been found to be as 2. Okay, two positive real root. K has been found to be as 1. The degree of the polynomial m has been found to be as 5. So therefore, by Descartes, the number of imaginary roots is being given by n negative of m positive k, which is 5 negative of 2 positive 1, which is 5 negative 3, which is equal to 2. So therefore, P of x will have 2 imaginary roots. Okay, so that would complete the solution for this question. So in all, so this would mean that P of x has 3 real roots and 2 imaginary or complex roots. Okay, so this completes the solution for this question.